G'day guys, we've got an integration question today where we're going to be using the method of U-Substitution to attempt to solve this relatively complicated trigonometric function here. Now I like to think of U-Substitutions as basically the chain rule in reverse. So what we're going to do, the easiest way for me to explain it is by doing the problem. So to start with guys, what I'm going to do is I'm going to substitute the 2x inside each of these trigonometric functions for u. So I'm going to have u equals 2x. Now because we're doing a u substitution, the next thing we have to do is we have to take the differential of each of our substitutions. So here we're going to go du with respect to x, and that's equal to 2. So what I can do is I can rearrange this particular differential and I can have dx is equal to du divided by 2. Cool. So let's take this u substitution and substitute the values that we've got for u, and we can also substitute the values we've got for dx. So what this means, guys, is we haven't taken the integral yet, so this is going to be equal to the integral of cos of u sine cubed of u times du on 2. Now what I can do is I can take the half, or the du on 2, I can take the on 2 component of that out the front of the integral because this is a constant. Cool. So now I'm going to do another substitution where I'm going to make the sine of u, so let's just draw an arrow over here. I'm going to make the sine of u equal to, let's call it v. So v is going to be equal to the sine of u. dv du is equal to cosine of u. So we can say that dv is going to be equal to cosine of u du. Cool. So now what I can do, guys, is I can substitute v into this equation here, and I can also substitute dv into this equation here. And let me show you how I'm going to do that. Well, I'm going to keep that half out the front of my integral. So we still haven't integrated this yet. Now, I know that cosine of u times du is going to be equal to dv. And I also know that v is sine of u. So I can say that this is going to be equal to v cubed, which is that sine of u there, times dv. Because we know that dv is cosine of u du, which is what we have there. So these two parts are going to make the dv. Now guys, I'm going to take the integral of this, and as you can see, it's going to be a lot simpler to take than this or this. So this is going to be equal to 1/2 times v to the power of 4 on 4 plus c, which is equal to v to the power of 4 over 8 plus c. And now, guys, what we're going to do is we're going to substitute what we know back into this formula. So this is going to be equal to v to the power of 4, which is sine of u. So sine to the power of 4 of u over 8 plus c, which is equal to sine to the power of 4 of 2x over 8 plus c. Now, this sine to the power of 4 2x, let's just work on that for a second because I want to simplify this out as much as we can. So what I'm going to do is I'm going to say that sine to the power of 4 of 2x, I'll move it up here, is equal to sine of 2x all to the power of 4. Now, we know that this is going to be equal to, I'm just breaking it right down for you guys, sine of x plus x to the power of 4. Now what I can do here is I can use my angle sum trigonometric identity and make this equal to sine of x cos of x plus cos of x sine of x all to the 4, which is equal to 2 cos x sine x to the 4, and which is finally equal to 2 to the power of 4 is 16 cos to the power of 4x sine to the power of 4x, and then we're going to use this as a replacement for sine to the power of 4 of 2x, and we're going to say that this is equal to, and this will be equal to, well, the 16 over 8 will cancel out to be simply just 2. We're going to have cos to the power of 4 of x sine to the power of 4 of x plus c. And this one here, guys, is our final solution. Now, let's just quickly go through what we did. First of all, we found the substitute for 2x in u. We took u out and then we differentiated, we took the 2x out and differentiated it. We then rearranged our differential so we could have a substitute for dx at the end of our initial problem. This one here. What we then did is after we'd substituted the u in, we then found another substitute in sine of u. We again took the differential so we could use that to substitute out the cosine u du. So we could end up with this particular formula here. We then could integrate this relatively easily. Then we began to substitute in our terms. And I would say, guys, that the hardest thing at the end is just making sure all of your algebra is correct so you end up with the right problem. So these problems can only be mastered through practice, guys. And like I say in most of my videos, you just got to keep practicing until you can't practice anymore. If you bang your head against the wall enough times, guys, eventually the wall will fall down. You probably hear that a lot from your parents and your teachers, but it is true. This only can be mastered with practice. So keep enjoying your maths, guys. If you have any problems, don't hesitate to leave them in the comments section below. Also, if you have any ideas for any other videos that you would like to see on maths, physics, chemistry or whatnot, also leave them in the comment section below. And finally guys, if you found the video helpful, please give it a thumbs up. Subscribe to my channel, I put out new videos as often as humanly possible. But until next time guys, whilst you're practicing, don't also forget to keep enjoying your maths. I'll see you soon.